Hello everyone, nice to meet you. And thanks for my invitation here to Professor Salandera. I really appreciate it. And I'm Federico Lombardi. I'm a PhD, former lecturer at the University of Southampton in the UK. And currently I'm the Chief Research and Information Security Officer of Conio. So I manage the topic related to research of the company and all the things related to the security. That in our company is quite the same things, because Conio is a crypto wallet that is mainly focused on the security of the custody system. During my academic career, I started with the cybersecurity applied to distributed systems. So the blockchain was the natural evolution of my path, where I applied cybersecurity to the blockchain to understand the security of the consensus and so on. And in this presentation that I call the key to not losing your keys, I will give you a security overview of the challenge and the problem that we have so far in the crypto ecosystem. So, starting from the beginning, with not working anymore. Now, yes, everybody knows what is a private key and a public key, so I will not go deeper on this. I just give you the details to let you understand the symbol that I'm going to look at in the presentation. So in the blockchain, it's particularly important, this notation of private and public key, because the public key is mainly what we can say like the address. It's not actually the address, because there are some other function applied to the public key, but basically something that's assign an identity to a specific person on the blockchain. While the private key is something that you can use to unlock this identity and to prove that you have the specific funds in the wallet. So what is a wallet? A wallet actually is not only things that contain the crypto. Actually, it's not something that contains the crypto, but it's something that contains the keys of your crypto. Because every time you need to prove to the network that you are the owner of the crypto, you have to sign a transaction with your private key to let the other nodes on the network understand that you really are the owner of that crypto assigned to your public key. So what is a wallet? A wallet is quite a complex software that has some specific module. One is for the generation of the key pair of the public and private key. Another one is for the custody of the key, especially for the private key, that is very important to keep very, very confidential. And then you have other functions that are important for the wallet, like the one to create and sign a transaction. So when you create a transaction, then you sign the transaction, and then you have to send this transaction to the blockchain. Finally, sometimes, hopefully, you have a balance of some tokens on the wallet. So you have the interface to fetch from the blockchain the information about your account. So it's important when we talk about security of wallets to understand where is the security, because sometimes we think about the custody like, okay, it's important to keep the key secret. Actually, it's important to generate the key in a correct manner and to keep the key secret. And I would say that the first part, so the generation of the key, probably is also most important rather than the second one, because while with the first one, with the second one, so with the custody, we have some layers now, like anti-malware and so on, that may protect the device from specific attacks. Here, we don't have anything else. So we have to generate the key properly, otherwise on the blockchain directly, someone is able to understand what is my private key, and we'll see how it's possible. So let's focus on the first topic, generation of the private key. On a blockchain, how I generate my wallet, my wallet address, so my public key. I will start from a pseudo-random number generator that I call random number generator because I don't have space here in the box. But actually, we know that the real random number generator doesn't exist because actually they are quite deterministic. So when you generate the random number, then you can infer your private key. From the private key, you derive your, this is an example on Ethereum, but it's mostly the same for all the blockchain in general. So you derive your public key, then you apply an hash function to your public key, and in the specific case of Ethereum, you have the address. This address here is the one that represents the identity, the account on the blockchain, okay? Now, it's nothing strange here, but it's very important that we carefully generate the random number. Because if you think about it, all the protection that we have about our private key generation for here is from this random number generator. So the problem is that if we have a random number generator that doesn't have enough, is not able to produce enough entropy, we may end up with a situation like I generate, for example, every time an integer number in an increased way. So, for example, 1, 2, 3, 4, 5, 6, 7. This is not to be a good pseudo-random number generator, obviously, because it's not random, no, it's deterministic. Then you may have, according to the random number generator, something like that. So a distribution of the number that you are generating across the space. If the number are well distributed on the space, it means that the number generator is quite good, okay? So now we know in cybersecurity that the security issues related to random number are infinite. And every year, at least 100 vulnerabilities about pseudo-random number generator arise every year. This is an example of specific classes. See, weakness is called weakness enumeration. And this is an example of all the problem that we may have with weak pseudo-random number generators. What happens if we apply this to blockchain? For example, in 2013, there were a vulnerability in the Java CPU random library for Android. And all the blockchain wallets using that specific library were affected to this problem. Okay, this was quite common. So it wasn't a problem of the specific wallets, but it was a problem of the infrastructure in this case, so of Java and consecration to conjoined. Okay, and this caused like 55 Bitcoin stolen in few hours. After that, some hacker was able to understand and exploit this vulnerability. Okay, so it wasn't a specific issue of the wallet, but it was a problem of the generator. And let's make a test. I also read some interesting research and paper about how to find collision in that specific context, like the work of Bernard. The hypothesis is that an Ethereum wallet generates in a deterministic way the private key, okay? And let's make an example. You remember the scheme that I put before, no? From the random number to the address, okay? Let's make an example. Imagine that I generate a private key by starting from this number here. So all 0, and the last one is 1, okay? Let's see what's happened. So imagine that I have a deterministic generator, and this is going to be my private key. Every 0, but least is 1, okay? I derive my public key. I apply the hash function, and I check this is going to be my blockchain address, okay? If I go to a blockchain explorer and I see this address here, I can see that we have 3,000 transactions, and also that this address is active, okay? This is not my address, but I can control this address because I have the private key. The private key is old 0 and the last 1. So actually, this is something like a wallet that everyone can use, because everyone can generate a private key like this and end up in a wallet that also has already tokens. So you believe that you are generating a new wallet with this key, but potentially you are ending up in a wallet that is of someone else. And we can say, okay, let's try to give a more complex example. Let's try to see, it's impossible to, I mean, it's impossible to try all the possible combinations, no? Because there are too many combinations to try, and we don't have enough computational power. We can try some alternative techniques like guessing, okay? So let's divide the space of the potential keys in 8 groups. And let's change only a subset of the bits of our key, okay? So the group A is composed by all 0, and this green number here is the one that we are going to change. So from 0, 0, 0, 0, 0, 0, 0, 1 to F, 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 F. Okay, that is it. Okay, so we are going to change only this number here. This is for group A. And we're going to repeat this experiment for group B, group C, group D, group H. Okay, that is the first number here, 0 and 1, and F, 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 F. If we run this experiment, we see this distribution. And this doesn't seem actually very, very well generated. I mean, I see a problem here because it seems that many wallets tend to generate key in that space and in that space rather than here. And this may be possible due to the fact that potentially many addresses also in the past have been generated with a weak pseudorandom number generator. Nobody actually knows how to infer specific number, but if I know this structure and I'm smart enough and I want to try to understand more, to try to steal the crypto from one specific wallet, what can I do? Is rather than focusing on this space where there are few points here, I can focus here and here, and I can try a brute forcing focalized only here on this point. And if we see a specific point here, the yellow one, this is that address, so every 0 but an 8 here. And if we see this address and we go to the blockchain, you can see that that point has been, that address has been stolen. All the funds that we have towards with address here. And this address collected with a bot, something like $50,000 million, because of it was able to understand other crypto wallets already existing. And potentially this bot is still active and is still trying to steal funds from others. So you can even have, for example, an hardware wallet and keep your hardware wallet completely disconnected, and you can say, I've never used it. It's in my pocket, but I've never connected to my laptop. I don't use crypto. I just have one Bitcoin there and I don't want to use it. But it doesn't matter, because if you have that your key is not properly generated, you potentially end up with your crypto stolen. And it's not a problem that is something related to the past, like the vulnerability of Android that we see in 2013, but it's something that is already active. The last episode that I experienced was in 2022, and if we see on August what happened, more than 8,000 wallets drained in few hours, something like $5 million of counter value of Solana and Ethereum. And it involves specific wallets, so we didn't get deeper about the pseudorandom number generator they have, but potentially it may have it was a vulnerability due to that. And also here they was tweeting something about it. and they was inferring that they was compromising the private key generation. So they suggest to move your crypto from the wallet potentially generated in a bad way to other system, like hardware wallet of multisig. Hardware wallet is actually not very correct, because also hardware wallet may have a vulnerability in the generation of the random number, because potentially is the same software. The only difference is that the vulnerability, the hardware wallet is disconnected from the internet. Other cases here, like from profanity, I won't get the 1-inch network advise people that was happening something with profanity as well. Other million of dollars drained from people. So type of custody. What we know about custody, we can separate in 4 main categories. You have the unhosted wallet that are the self-custody wallet, like Ledger, MetaMask, Trust Wallet, and you are the owner of the key. So you manage directly the key. You have delegated custody, where others are managing your wallet, or you have hybrid solution like MPC wallet and multisig wallet. The difference is that in a MPC wallet, you have a single key that is actually split in n shards, while in a multisig wallet, you have n independent keys, not split. So you have n independent keys. This is the main difference. Let's say 1 key split in n parts, 3 keys which are independent. Then you have the other difference is that with unhosted wallet, you have dedicated key set for each user, while with delegated custody, they have omnibus wallet, which manage the crypto of all the customers. So for example, this is an example. If you have your crypto on Coinbase, you don't have your own address, but they have the crypto together with the other customer. While in a wallet system, you have your dedicated key set. And why it's important? Because in case of compromission of a private key, all the customers here are compromised, while in case of compromission in a wallet, only a specific customer is compromised. Also, unhosted wallets are great, but the problem is that for standard people, not very techy, it's quite hard to use, because you have to manage the key and so on, and maybe people is not very comfortable with this kind of technology. While with delegated custody, you have recovery in case you lost the password, no? These kind of things usually doesn't happen. But on the contrary, if you delegate your crypto to someone, can happen different kind of things. So they may end up with losing everything, not because of you, but because of them, but you lose your money. That's why they say, not your crypto, not your key, not your crypto. Obviously, there is a matter of trust. In a unhosted wallet, you don't need trust to anyone, while in a delegated custody, you need high trust the custodian as well. And security, it depends. Obviously, it's hard to say that one solution is better than another. It depends on how the security is implemented. And the only thing that I can say is that, for example, in MPC and multisig, here we are introducing potentially some issue with the MPC protocol, because something that we are adding. While in a multisig, we are secure by design, because we are using the native multisig on chain. Here, the multi-signature is actually off chain, managed by the MPC protocol. So when we talk about collision, single sig and MPC, we can say that mostly are the same, because potentially we have a single key, and if we compromise the way to generate that key, we actually compromise the entire system. In a multisig is a bit different, because we have 3 keys. So obviously find the other 2 keys that can control the same wallet is exponentially harder than find just another key. And also in the overtime, MPC experience some vulnerabilities because it's a novel technology. And of course, we have to care about the security of the protocol. Otherwise, we may end up with also security introduced by the MPC protocol itself. Then, talking about custody, we know also that it's important to manage the key properly. We can store the key with through hot key, warm key, and cold key. The difference is how we store that key, like in device connected to the internet, device connected to the internet, what with some intermediary feature to unlock the wallet, and cold like a physical device that is completely disconnected. Obviously, pros and cons. Here is a fast solution with less security. This is a trade-off. These tend to be safer, but obviously slower because it requires a continuous interaction with the physical device. So what we do in Conio? I talk a lot about everything, but we don't. I didn't tell you exactly what we do. We start as a Bitcoin wallet with a multi-sig technology, and what we have proposed to the customer is a wallet based on 3 keys. Specifically, we have one key that is the user key that is generated in the mobile application of Conio. Conio has a mobile application that you can find on a Play Store and Apple Store. So this key is generated on the secure storage of the device directly when you create the wallet. In the same time, Conio generates a key connected to that user on the cloud trusted execution environment. And also we have a recovery key that is split in N shards in a way that you can recover the funds in case one of the other 2 keys is no longer available. So if the user lost the primary key and he doesn't remember the seed phrase to gain access to the Conio position, Conio doesn't have that key. So what the user can do is to KYC with Conio and ask for the recovery. And the recovery means that Conio can use the key of Conio, the key of that parties, and regenerate the user position. Obviously, here we can see that there are multiple keys because this third key is split with in N shards assigned to different parties in order to not to rely to a single third party and mitigate, let's say, the risk of a single party composition. And also the good thing is that in the generation, we use 3 different technology for the random number generator. Because if we find that in, let's say, Python, the most common PRNG is vulnerable, we know that here we are not using it because here we use something else. And here we are not using it because we're using something else. So the mitigation of our solution for the random number generator obviously is not something that we say we are not vulnerable to anything, but it's something to mitigate the potential issues that we may have. And also we are doing now further activities, so from improving the technology and the security of the wallet to an SDK to integrate Conio directly within the banks. We are now have 2 active integration with 2 Italian banks. We are working on a tokenization project and on a euro token for retail and B2B use case, and we are doing also still some research activity. One interesting thing that I would like to give you like an example is this one, Habits. We are going from a crypto wallet to a token wallet. So we started as a crypto wallet, but we saw that with tokenization, we need to modify something to make the user experience much better, no? So for example, from the automatic payment of the fee that are completely invisible for the user to other things, we are integrating a crypto feature within the user wallet like this. This is a project that we've done with an energy provider in Italy, Enel. And what is done is we have tokenized energy plan, real plan that they have. You can buy the token, and the user can see directly here, like if it's simply a solar panel that he has with a specific BAT. And then there is a smart contract that, together with an oracle, read directly from the real plant the energy produced and recognize to the user a token that gives the production to the user. And this production is like if you have on your roof directly the solar panel installed. But maybe you live in a condo, you live in something, you live in a place where you can't install any solar panel. So this is a solution to overcome this potential issue. This is some research that we have done, and thank you.
Are there any questions? Yes, please. You can use this one.
Yeah, so, ciao, come stai? Bene. Could you go back to the sound of the
Just keep it close.
you go back to the sound of the 3 keys? I just want to understand something about it. Yeah, so does that mean those 3 keys have access to the wallet?
The wallet is a multi-sig 2 out of 3, if I didn't mention it correctly.
Okay.
It means that you need 2 out of 3 keys to sign a transaction. Every transaction must be signed by 2 keys. So if the user, together with Conio, usually sign a transaction. So the user, through the application, wants to send Bitcoin, send the transaction, it is sent to Conio, Conio co-sign the transaction, and Conio send to the blockchain the transaction. In case the user lost the key, the user asks to Conio to enable the recovery procedure through the KYC, and Conio use the second key through a quorum of third parties. Also, in case of Conio disappear because Conio fail as a company, is bankrupted, and so on, potentially the user doesn't lose anything because he has the key, and together with the quorum of the third party can rebuild the position.
And I'm wondering about because the best way to make a key is obviously if you any code is deterministic, right? So if any calculation you can do, it will just be eventually easy to reproduce and find what key it is. So the best way of making a key that's really random is by getting a human input that's totally random, using the idea I have in language, asking a user to write a phrase, and whatever phrase he writes, and plus the time he or she or they use to do every key input, can give a random number that gives that random key.
Consider that the generation of the private keys is quite a huge topic, and there are maximalists of Bitcoin especially that suggest to roll a die.
That's why I thought as well.
Yeah, but also they tell you that there are specific die that you have to buy because a die may have some imprecision. Exactly. So potentially it doesn't exactly the same the probability to generate 1 or 6. Okay, so obviously it's hard to find a completely random process.
Yeah.
Everything may have some some deterministic part that make weaker the random number generating. Obviously, now the accuracy that we have with the pseudo random number generator is quite high, so we can rely on the pseudo random number generator in the market. Rely doesn't mean that are secure enough.
Yeah.
Magari, we can rely now, today, maybe tomorrow, no.
Because say there's 7 billion people on Earth, and every person has a wallet. If you do,
This is another thing. This because you are increasing the possibility of a collision.
yeah,
But in general, we also have to reduce to maximize the entropy,
exactly.
to maximize the space that we need to cover with the generation of the number.
Mhm.
is hard with pseudo-random number. Maybe with a quantum computer, if you put your qubit in a superposition and you are determined 50% one bit or another, you can generate bit like this. Maybe it's more random than a pseudo-random number generator.
Possibly, yeah.
Are there any other questions? Yes? Wait, just a second. I'll bring it.
If the user loses key number 1 and then asks for key number 3, from what I understood, it's actually Conio that recovers key number 3. So for a brief moment, is Conio in possession of key number 2 and 3?
No,
How is
no.
transferred?
Conio is only the key number 2. The key number 3 is split and assigned to third parties like notaries, lawyers, banks. And to use that key, you need a quorum. Imagine that you have 10 keys and each of these shards here is assigned to a different part. Okay. To use that key, you have to obtain a quorum of signers here, but these are independent parties from Conio. This is not Conio. So like in a standard procedure, Conio needs to say to the third parties, we need a quorum to recover this position. Conio guarantees the identity of the user through the KYC, and the procedure starts. Otherwise, it's like that we can actually control the key of the customer.
Fantastic. And then the end you threw in the curveball with the electricity.
Go closer.
The transferability of those tokens. Can you go to that slide?
Which one?
I think it's the last one on this one. Yeah. Can you explain this a little bit further? I'm working on something similar with water and energy as well.
This is a project where we have solar panel and wind plants. No, so you can buy token that represent watt. A single token is a single watt of one of the plants. You can buy, for example, 100 token. It means that you're buying 100 watt of solar panel.
What is that? I'm sorry. What?
Oh, sorry. Yeah, watt.
Sorry.
And
Okay.
it's like that you have this panel on your roof. Okay, but actually it's virtual. Then there is an oracle that reads from the real utility scale the generated power, and a smart contract calculates according to the number of tokens you have the produced energy that you deserve. Like virtually, you have produced this energy,
So then
and send these tokens to your wallet.
And then they have to accept it at the local level as well, right? To be able to transfer or sell it.
Yeah, this means that at the end of the month, the billing will consider that specific production that you had, the virtual production that you have, which has legal value, and they apply a discount on your bill, like if you have a roof and you auto-generated this.
What if where the energy is produced in one area is worth more than the other area? How can you stop arguing about it?
If you produce more energy, this is why we want an euro token. So when you're producing further energy, you have to sell it and they give you back money. But we want to stay on chain, avoiding bank transfer and so on. So when in the phase 2, we will go further with this project. When the user will produce more energy, they will give back euro token directly on this wallet. And this wallet can be used for other things, like renting an electric car and so on. And in general, this may be potentially a euro token wallet that you can use to pay in a restaurant, in a coffee shop, or so on.
Awesome. Yeah. What I'm trying to do now is peg it to a carbon credit. So that has an outlet there. And
Exactly. You can make it. This is just an example of a project. This is the idea of things we are working on. Dedicated wallet with tokenization project, and all of them moved around an euro token that you can use on different environments.
So Federico, can you come back to this question, to the 2-3 case?
Yeah.
So I wanted to explain a bit more since I know a little bit how it works. So if you lose your key, so the other 2 keys don't reconstruct your key.
Oh, yeah, exactly.
They just, so there will be new keys created for the 3 of them. So there will be more address. And they use the last 2 keys only to sign a transaction, send your Bitcoin to the other new address.
Because you will never recover it,
Exactly.
because we don't have it.
In the wind farm scenario, in the wind farm scenario, basically saying you have a virtual share in a solar farm and be able to get tokens. Because
Yeah.
your panels generate.
Exactly.
It's very interesting.
Imagine here, you have this place, but you live here, but you can't, you don't have a roof, so you can't put the solar panel here, no?
Good way of kind of incentivizing the industry to build more.
Yeah.
So that end users can have a share.
I mean, this is the business of the electric company, no? But our business is another one, is selling wallets.
Yeah, but it's important also.
It's important to make it consistent, obviously.
Okay, another one. There was, as far as that. Go ahead.
Right, it's the same. Okay.
I'm exploring, proof of work or cloud compute, in terms of renewable energy. So, when your batteries are full, and in my case, your water tank is full, but the sun is still shining and the solar panels out, instead of selling that back to the power company, right? Putting it to work in, either compute or
Mining, since,
Right.
yeah,
proof of renewable work.
yeah,
And then, transferring that to other tokens, for other.
absolutely.
Yeah,
This is a,
transferring power over the internet.
you got a point where we want to ride with this project. This is something that can create potentially virtual money, and you can say, okay, I don't want to earn euro token from this. I want to use this, for example, for mining. So you can virtually mining Bitcoin and accumulate Bitcoin mined there.